Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.5 of O-level and IGCSE additional mathematics. So jumping straight in, what is this exercise really about? So it's about the roots of quadratic equations, as we can see by the topic of the chapter, topic of the exercise. So basically, I think you should know some new things for this. Some of you may know the rules I'm going to explain now, some of you may not. So please do listen carefully now. The thing is, we all know the quadratic formula, which is negative b plus minus under root b squared minus 4ac divided by 2a. We all know this formula as we have solved many quadratic equations through these in our previous chapters. I think, yes, we have done it in chapter 1 also. So the thing is, if we just see the part under the under root, I know it's getting a bit confusing, but please bear with me. So if we see the part which is trapped in this under root, it's called b squared minus 4ac. Okay, and this is called discriminant. Okay, so the part of the quadratic formula underneath the square root sign is called the discriminant, as we can see, which is b squared minus 4ac. So it's just pure, you have to purely memorize it for now. And what's the concept behind this thing? So the thing is, if we we have solved many quadratic equations through this formula, and we can get three types of answer through this equation. For example, we have this equation x squared plus 2x minus 8 is equals to 0. Okay. So the first type of answer we are going to get is two different values for x. So x may be 2 or x may be equals to -4. So we have two different values for x. The second type of answer would be x. For example, we solve the equation x squared plus 6x plus 9 is equals to 0. And if we input the quadratic formula into this, the second type of answer we would get is the same values of x two times. Okay, so that would mean two equal values for x, or in other terms, two equal roots for x. Okay, so that's the main concept behind it. And in a way, we can say that we get only one value for x. We can say that. The third type of answer we can get is we get no solution. How can we get a no solution? When the part under the under root is negative, or we can say which is lesser than 0. So the part when the part under the under root is lesser than 0, we are going to get a negative value. So that would mean that our answer would have no solutions at all. So there are some basic rules while using the discriminant, which allows us to find if we have two different answers for x, or one answer for x, or either no solutions for x. So how can we find this out? So we can find this out by using the discriminant, which is b squared minus 4ac. And there's some rules behind this discriminant. So if we take this b squared minus 4ac, and the answer for this is greater than 0, okay, so we are going to say that we are going to get two distinct roots. Okay, so if the answer beneath the under root is a positive value, or you can say it is greater than 0, it is going to get two distinct roots. And as we can see in this example, they solve this up, -2 plus minus under root 36, and this 36 is a positive value. That's why we are getting two distinct roots. The second rule is, if b squared minus 4ac is equals to 0, then we are going to get two equal roots. That would mean if the answer underneath the under root is equals to 0, exactly 0, then we are going to get two same values for our quadratic equation. And as we can see, -2 plus minus under root 0 divided by 2. And basically what it means is whenever we get an exact 0 underneath the square root of our quadratic formula, we are going to say that we are going to get two equal roots for our answer. And I'm going to explain this with the help of a graph. Just let me just complete this. So b squared minus 4ac. If the answer beneath the square root is lesser than 0, then we can say that we are not going to have no solution. Meaning, if the under root contains a negative value, we are going to say that it has no solution. It's going to give a mathematical error. And as I promised, I'm going to explain you this concept with the help of a graph. So basically what's happening? When we say that, let's take the first example. We say that b squared minus 4ac is greater than 0. And we always know when it's greater than 0, what's going to happen. So if I would make a graph, it's going to come here. It's going to be greater than 0. It's going to follow this format. Okay. So it's going to be something like this. Okay, when the discriminant is greater than equals to 0, we get a graph of something like this. Okay, and as we can see, when we sketch this graph, we are going to get two intersection points on the x-axis. Okay, so that's why we can say we are going to get two distinct roots. So this point is a different value and this point is a different value. So they are both distinct. Okay, and then when our for the second option, b squared minus 4ac is equals to 0, we are going to get two equal roots. How are we going to get it? For example, a graph, and when we say that b squared minus 4ac is equals to 0, what we mean is this. Come here. A second. Okay. So when we say that b squared minus 4ac, or we can say the discriminant is equals to 0, we are going to get one equal root. And as we can see, this is the type of graph that will be formed when the discriminant is equals to 0. So it's giving us only one value. Okay. And that's why we say that our answer is actually going to give us two equal roots. Okay. Because we are only getting one value from the graph. And for the third option, which is b squared minus 4ac is lesser than 0, we say there is no solution. And basically, if we draw the graph of the discriminant being lesser than 0, we get a graph of something like that. We make a curve. Yeah. And we get something like this. And as you have noticed, this graph is not at all touching the x-axis. Okay, it's even though it's touching the y-axis, it's not touching the x-axis. And when it's not touching the x-axis, it's not going to give us any values for x. And thus, we are going to get no solutions for this answer. And that's basically the concept behind the different values for the discriminant. So as a recap, we are going to just summarize now. B squared, when the discriminant is greater than 0, or we can say if it has a positive value, we are going to say that it has two different roots, or we can say two different values for x. If the discriminant is equals to 0, it's going to have the same values for x. I mean the same two values for x. And if the discriminant is lesser than 0, or we can say it is a negative value, we say it's not going to have any solution, as the graph is not at all, or we can say the parabola is not at all touching the x-axis. So that's it. This is just summary behind the concept in this exercise. And if you get it, if you get it what I'm saying right now, I think you will find it easy to solve the rest of the exercise. So just real quick, we are going to solve this up. So they're asking us right now, state whether these equations have two distinct roots, two equal roots, or no roots at all. Hey, just let me get rid of this. Okay, so for part A, we are going to say x squared plus 4x plus 4. Okay, so as this is the first question, I'm going to go really detailed for now, but after around 2 to 3 questions, I'll be a little fast than normal. So whenever we use the quadratic formula, we have to find the three values we are going to substitute as A, B, or C. Okay, so they are taken as, for example, let me just write a basic quadratic equation. So a quadratic equation is basically following this format: ax squared plus bx plus c. And when we say this format is being followed, we say that the coefficient of x is called b, the coefficient of x squared is called a, and c is a constant. Okay. So right now, if we see here, x squared has no coefficient, while we can not see that coefficient. However, we can say it is an imaginary one. And if you don't know what I mean right now, you should take basic maths class. So the thing is, a is equals to 1. The coefficient of x is 4, so b is equals to 4. And the constant is 4. Okay. Now substitute this value with the discriminant. Okay. So let me just clarify the fact that I've told you we are going to find every value with the help of the discriminant. We are not going to apply the whole quadratic formula which is written here. We are only going to use the discriminant to find the number of roots for our equation. Okay, so now we are just going to use our discriminant b squared minus 4ac. We are going to get what value get. So 4 squared is 4 4 is 16 minus 4 multiplied by a, which is 1, and c, which is 4. So if we multiply it, we are going to get 16 minus 16, which in return is equals to 0. So we all know that if b squared minus 4ac is equals to 0, we are going to get two equal roots. Again, I'm going to just give a short recap. B squared minus 4ac is greater than 0. We are going to get two distinct roots. Distinct roots. And if b squared minus 4ac is lesser than 0, we are going to get no solution because it's going to be a negative value. Okay, so right now we are getting b squared minus 4ac is equals to 0. So that would mean we are getting two equal solutions for our answer. For part B, it's really basic. This question 1 is really basic. So let's continue. X squared plus 4x minus 21. We have to solve this. So A is equals to 1, B is equals to positive 4, C is equals to negative 21. So again, we are going to say B squared, which is 16 minus 4 multiplied by 1 multiplied by negative 21. So it's going to give me 16 plus 21 fours. Let me just do this. 21 fours are 84. So it's going to give me 16 plus 84, which is 100. So again, this is a positive value. 100 is actually greater than 0. So when we get b squared minus 4ac is greater than 0, we are going to get our answer is two distinct roots. Okay, this is it for part B. Wait a second, why did I erase this? Let me just use. Okay, so for part C, we have x squared plus 9x plus 1. Again, we are going to follow the same pattern. A is equals to 1, B is equals to positive 9, C is equals to 1. And the thing is, what we are going to do is b squared 9 9s are 81 minus 4 multiplied by 1 multiplied by 1. So the answer is going to be 81 minus 4, which is 77. And 77, as we know, is a value which is greater than 0. So whenever we get a value which is greater than 0, we are going to get our answer as two distinct roots. And that's it. Okay, for part D, we have x squared minus 3x plus 15. So it's going to give me a is equals to 1, b is equals to -3, and c is equals to positive 15. Again, b squared -3 squared is positive 9 minus 4 multiplied by a multiplied by c. And that's going to give me 9 minus 4 multiplied by 15 is 60. So 9 minus 60, and 9 minus 60 is equals to -51. And as we know, -51 is a value which is lesser than 0 because it's negative. And when we get values which are lesser than 0, we are going to get the answer, which is we are going to get no roots for our answer. And that's it for part D. I know this seems really basic for now, but as we go through the questions, it's going to get a step up and all. However, I agree with you that this exercise is comparatively quite easier than the rest of the exercises in this book. Okay, for part E, we are going to say that is x squared minus 6x plus 2. Again, a is equals to 1, b is equals to -6, c is equals to 2. If you do a step, every equation, every solution step by step, you are going to make your life easier. Don't just go up and just directly try to solve everything mentally or whatever. Just try to make it, do it step by step, and it's making your, and it's going to make your errors lesser. Okay, so for this one, we have a is equal to, so b squared, which is 36, minus 4 multiplied by a multiplied by c. 4 2s are 8. So 36 minus 8 is equals to -8. Is going to be equals to 28. So as we know, again, this 28 is a value which is greater than 0. And when we are going to get values which are greater than 0, we are going to say that our answer is two distinct roots. Okay, for part F, we have something similar. We have 4x squared plus 20x plus 25. Okay, so for this one, a is equals to 4, b is equals to 20, and c is equals to positive 25. Okay, so b squared 20 squared is equals to 400 minus 4 multiplied by a, which is 4, multiplied by c. So 25 multiplied by 4 4 is 16. So it's going to be 400 minus 400, which is equals to 0. And again, when we are going to get our answer equals to 0, we are going to get two equals roots. Answer is equals to two equal roots. And that's it. So this is it for part F. It's really easy. I know it looks like primary stuff, but still, we have to do it. I mean, these questions may seem easy, but if you have done each and every part, if you have understood each and every step, then if any question which has a harder concept and follows the same rules, you're going to easily solve that. So it's going to seem basic for now, but it's going to help you a lot. So for part G, we have 3x squared plus 2x plus 7. Again, we have a is equals to 3, b is equals to 2, and c is equals to positive 7. I'm going to go a little bit faster for now. because I've solved a hefty amount of questions till now. So b squared 4 minus 4 multiplied by a, which is 3, multiplied by c, which is 7. 4 3 is 12 multiplied by 7 is 84. 4 minus 84 is negative 80. So when we get negative 80, it's a negative value which is lesser than 0. And we get when we get values which are lesser than 0, we are going to say our answer has no roots. Similarly, for part H, we have 5x squared minus 2x minus 9. So a is equals to 5, b is equals to negative 2, and c is equals to negative 9. Okay, so we have these values, just directly put them in. Negative 2 squared is positive 4 minus 4 multiplied by a multiplied by c. So we are going to get 5 multiplied by 9 multiplied by 4, 180. 4 minus 180 is equals to negative 176. And as this value again is equals to is lesser than 0, it's going to have the answer which has no roots. And that's it. This is it for question number 1. I'll meet you in the next lecture with the rest of the exercise. So thank you till then. I'll meet you in the next lecture.